Have you ever seen a robot do something that makes you stop and question what humans can still do better? What if I told you that a humanoid robot has just performed movements that go beyond normal human physical ability? Not in a lab test, not in theory, but in a real public demo that shocked engineers around the world. This is not science fiction, this is not a concept animation, and this is definitely not hype. China's new T800 AI robot has just crossed a line that many experts believed was still years away, and the global robotics community is still trying to catch up. When the demo footage first appeared online, most people thought it was edited or sped up. But once engineers slowed it down frame by frame, the reality became even more disturbing. The T800 didn't just move fast, it moved with a level of precision, balance, and real-time decision-making that most humans simply cannot match. This video is not about showing you impressive clips. It's about breaking down exactly what happened in that demo, why it matters so much, and why this single robot may represent the beginning of a completely new era for humanoid machines. At first glance, the T800 looks like just another humanoid robot. 2 legs, 2 arms, a familiar body structure. But the moment it starts moving, you realize this is something very different. The robot performs rapid directional changes, controlled jumps, complex recovery motions, and dynamic balance corrections that would challenge even elite athletes. What makes this shocking is not just the speed, but the control. Humans rely on muscle memory, reaction time, and years of training to perform coordinated movements. Yet the T800 is doing all of this through artificial intelligence, sensors, and actuators working together in real time. Engineer, the company behind the T800, didn't simply make the motors stronger. They redesigned how the robot thinks about movement. Every step, every shift of weight, and every micro-adjustment is calculated thousands of times per second. The actuators inside the T800 are capable of delivering explosive power instantly. But power alone is useless without control, and this is where the real breakthrough happened. Advanced balance algorithms allow the robot to predict instability before it happens. Instead of reacting after losing balance like most robots, the T800 anticipates it, adjusting posture and force output in advance. This predictive balance control is something humans can't consciously do. Our brains are fast, but not that fast. The result is a robot that looks almost unnaturally stable, even during aggressive movements. One of the most jaw-dropping moments in the demo is when the T800 transitions between movements without hesitation. There is no pause, no recalibration delay, no visible processing lag. This tells us that the AI system is not just following pre-programmed sequences. It is actively interpreting sensor data and making decisions on the fly. Cameras, force sensors, joint encoders, and inertial measurement units are feeding data into a neural control system that continuously adapts to changing conditions. If the ground shifts slightly, the robot adjusts. If momentum changes, it compensates instantly. This level of real-time adaptation is what separates advanced humanoids from experimental prototypes. And this is why the robotics world is stunned. Until now, many believed that humanoid robots would remain slow, cautious, and fragile for years to come. The T800 challenges that assumption completely. It proves that humanoid robots can be fast, aggressive, and physically capable without sacrificing stability. This has massive implications. In industrial environments, robots like the T800 could navigate complex spaces designed for humans without needing safety cages. In disaster zones, they could move quickly over rubble, climb obstacles, and recover from slips without shutting down. In the future, this kind of physical intelligence could redefine labor, logistics, and even security. What makes this even more significant is the speed at which China's robotics industry is advancing. Just a few years ago, companies were struggling to match the basic locomotion capabilities of Western humanoid projects. Now we're seeing demonstrations that leapfrog expectations entirely. The T800 is not being presented as a distant concept. It is a working platform, and that sends a very clear signal. The competition is no longer about who can build a humanoid robot. It's about who can build the most capable one, the fastest one, and the one that can operate reliably in the real world. And this brings us to the slow-motion breakdown. When you slow the footage down, you notice subtle details that most viewers miss. The way the robot's foot contacts the ground, distributing force evenly. The micro-corrections in the torso that keep the center of mass perfectly aligned. the synchronization between upper and lower body movements that prevents energy loss. These are not accidental. They are the result of deeply integrated hardware and AI design. This is why experts are taking the T-800 so seriously. It's not just impressive today, it shows a clear roadmap for what humanoid robots will be capable of very soon. And here's the part that should really make you think. Once a robot reaches this level of physical capability, software updates become the real limiter. The hardware is already there. As AI models improve, as training data increases, and as learning algorithms evolve, robots like the T-800 will only get better, faster reactions, smarter movement strategies, and even more human-like adaptability. This is why the T-800 isn't just dominating conversations right now. It's forcing a global reassessment of timelines. What we thought would take 10 years might take 5. What we thought was impossible may already be happening. So the next time you see a humanoid robot moving awkwardly in a demo, remember this moment. Remember the T-800. Because this is the point where humanoid robots stopped being fragile machines and started becoming physically intelligent entities. And if this is what we're seeing today, the question isn't whether robots will match human physical ability. The question is how long before they consistently surpass it. Stay with us, because the future of robotics is unfolding faster than anyone expected.